So let's continue. So did your test already happen or is it going to happen?
It already happened.
It already happened. Okay, okay. So I guess now we
Yeah,
are more relaxed. Okay.
yeah.
So today my plan was to, because yesterday we discussed this AMGM inequality, but we kind of just defined it, proved it, and did a few simple examples. Okay. Now I would want to go into some techniques of it, some because we're preparing for an Olympiad, so just knowing the inequality, everybody knows the inequality. You'll have to have the strategies which you can then practice with problems and yeah, get good at it. Otherwise, it's no good just knowing the inequality. So I'd just like to discuss a few strategies, but there will be extensions of what we did yesterday. So you remember one of the problems yesterday, we had a situation where we had some square terms on the right side, right? And we had to apply AMGM on this, right? So we strategically, brought the square terms on this side by some different kind of using some different identity. Okay, you remember that, right? Like when you squared an inequality, you got something like this. So this was not good. So we did something else intentionally so that we bring the square terms on the left side. Okay, so we will see this in a more complicated situation. Okay, in a problem. This is a very special technique. Let's see. Yeah. So let's just start with the problem. Yeah, there's no theory here, but just the problem. So we have three numbers A, B, and C, which add up to 3. And obviously, these are all positive numbers. Okay, positive numbers. Now, what we want to show, or it can even be put in a different way as find the minimum of, but I just write it like this. So it's a cyclic kind of inequality. A by 1 plus B square, B by 1 plus C square, and C by 1 plus A square. So yeah, just show that this is bigger than 3 by 2. And of course, if you can use some other inequality to do it, that's also perfect. Yeah, yeah. There's no yeah thing that you have to use this only. Yes, Jeet, any ideas?
Um,
You could certainly do this by bashing it, right? You could maybe just multiply out everything, and that's probably one way, a last resort,
yeah,
right? But that you can, of course, do on your own as well. But we want to just learn a technique. So I'll just, and of course, later on, when you learn more techniques, like there is something called Chebyshev inequality, you may have heard, and there are techniques
yeah,
associated with that. Maybe with that also, this problem can be done. But right now, I just want to display the AM, and I'm not sure if this is very amenable to that technique or not. But certainly, what I'm going to show is something interesting. Let's see. So if you're going to try to apply term by AMGM, okay, then you see if you want to make this linear, right? Because that's how the conditions, all the other conditions are. But the
yeah,
problem is that it's in the denominator. So if you do 1 plus b square equal to 2b, this is okay. It's on the greater side. But the moment you reverse it, it just everything gets some sense gets spoiled, right? It's on the less hand side, and this is the problem. Okay, whenever they have square terms, it's in the denominator of a greater hand side, as you can understand. It's not good, right? So bring, we want to convert this inequality to something like this. Had it been like this, you could have gone forward with this. You understand what I'm saying, right? Had it been
yeah,
instead of this, had it been like this, you would have gone forward. So then try to do some manipulations and convert this inequality to, the left hand side less than something. You see? Uh,
yeah.
yes, try doing that. So this seems like a very contrived term, but there are many problems which can be done like this. So that's why probably it's still useful sometimes. Yes. So now the question is, how do we do that, right? Hmm. Okay. So let's see how we can do it. Okay. So we are just going to manipulate the numerator. So of course it's going to be term by term. What will apply to one term will apply to all. So we'll just focus on one term. So it's very simple. In fact, it's just that you have to just manipulate the numerator. So the simplest way is you add this and subtract this. Okay, something like this, or just do this. You see, what I'm trying to do is I'm to take out something and I'll be left with a negative. Okay, so we will get, as you can understand, this will be equal to a. This will be equal to a minus this. Okay, so you see this manipulation, right? Now we are in the right side.
Yeah,
Okay, now we are on the right side. Yeah. So I'll just quickly rewrite this entire expression, what it will become. So minus 3 by 2 will be greater. So now this is exactly what we kind of wanted. Mm, yes, I think this looks good. Let's see. Let's see if it works. 1 plus c square and ca square. Yeah. At first, it's a little strange kind of manipulation, but yeah, if once you see it works, then it works. So this is the thing. Now, how do we prove this? Now you try to apply your AMGM the way we did, okay, in the first time, and you see it will work. So for example, you
Yeah.
look take this term. So obviously you want to simplify the denominator, and the way to do it through inequalities is to apply AMGM on that, and we are on the right side for this one. So yeah, just quickly write because we already did it once. So this will be, yeah, 2 by b, right? No, no, 1 by 2b. What am I doing? So it's going to be 1 by 2b, right? And then of course the rest of the terms just multiply as you have to, and you do this, and this becomes ab by 2. Okay, and so this entire summation would be less than this, right? So now what should be the next step? If let's say we did till here, so what we have right now is the right hand side is less than half of this. So what should we do next? So I'll just expand this.
Um, do this for wait. Can you go over what you did in the last part?
In the last part, yes. So I just applied. So see, we had to prove this, right? This is
Yeah.
equivalent to, so we have not lost anything yet. It's not lost any information. This is equivalent. Now I know that I need to apply AMGM on the denominator. It's suggested because I want to simplify the denominator. I don't want a plus here, right? So that's why I just applied AMGM on that. Now if you apply AMGM, then this is what you will get, right? This is what you get. Is that okay? Yeah, because
Yeah.
yeah, okay, so that's okay. And then I just added up, did the same thing for all the terms. Of course I don't have to separately do it, right? So
Yeah.
yes, I guess then you understand that, right? So since it's cyclic, so it's the same thing. um yes, right. So I just erase this part. Yeah, so now we have this, or just in short, we have this. Okay, what should, now my question is, what should we do next? What should be our next step?
Um.
Yes. So it's just that, see, because we have this as our ultimate goal. We want to show that our expression is less than 3 by 2, right? So at this point, because we have simplified the expression, we would want to show that this is less than 3 by 2, that this is less than 3 by 2.
Yeah.
Yeah, and it will be enough, though it may not be necessary. This may not be true, but it's just a matter of faith here, right? We are thinking that if we can do this, then it's enough. That's true, but this may not be true. Okay, this, it may happen that this bound right here is not a good bound, isn't it? Suppose, I mean, if you want to show that 2 is less than 10, but if you conclude 2 is less than 12, that's not going to help you to show that 12 is less than 10. It's something
Yeah.
like that, right? So yeah, so this is the thing. So when we do chain in, this is like a chain of inequalities. We have to be careful at what chain we are, how much we are losing. Okay, and usually it will not work if the equality for this inequality and the equality for this inequality are different. If the equalities hold at different points, then it's not going to work. But you can check in this case, though I don't think that much analysis is needed in this, that the equalities on both the things happen when all the terms are equal, and so they are equal to 1. Okay, you can check that. But yeah, that's not needed probably in this. So now basically we just want to show this rather simpler inequality. So can we do this? Can we show this?
Maybe you can just do AMGM on this.
Yes, right. So can you just say the details quickly maybe? So we want to show this.
3 cube root AB. A squared, B squared, C squared.
Sorry,
I
3.
think
Okay.
like taking AMGM of
Term
maybe
wise.
A squared, B squared, C squared would be better.
Um,
This
yes.
plus A squared, B squared, C squared.
Oh, this plus a square b square c square. Okay. So let's see. And it has quite a standard inequality to know anyways. But yeah, we'll see. So
Yeah.
if we take plus this, then okay.
A squared times B squared times C squared.
Oh, I'm sorry. Yeah. Okay. 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 So you want to apply it. Okay. Then no, no. But see, you want to show it's less than something. How are you going to treat this as a AM?
Yeah.
Uh, if that's what you're going to do. That's what I thought. Uh, okay. Like you want to show it's less than something, right? So you can't treat this as the AM of something. That will not be good.
Yeah.
Okay. Yeah. Yes. So essentially, you see, it follows from, and I'll show you the technique. It's very simple, but basically, you see, there is this inequality which you may note is very important actually. That 3 times this is less than a plus b plus c whole square. Yeah, and it's basically very simple to prove. Okay, that this is less than a square plus b square by 2. BC is less than b square plus c square by 2, and CA is less than c square plus a square by 2. Then you do 2 times this,
Yeah.
right? And you add a square, b square, all that, right? So basically, yeah, you can do it. Yeah. So then you'll see if that this follows from there. Okay. So this is a rather simple, but this technique right here was something interesting, and the specific way to actually uh, come on the right side, not right on the, yeah, this is the denominator. Then if you're going to apply AMGM, this should be on the less hand side. Okay, something like that. So you'll have to do something like this. Okay, so change the numerator. Okay, or maybe you could have subtracted 1 from 1 and it would have still worked. Okay, that's another way in which it's usually presented. Okay, but yeah, you can play around with that yourself. So yeah, this is the very interesting technique. It's like a reversing, going on the reverse on the opposite side and then doing it. So let's just do one example of this, just one more. There are many applications of this, but I just want to do one more to just know that this idea goes through. So yeah, let's do it. So this is for 4 variables, but it's not the same. It's not an extension, slightly different. So we have 4 numbers and they're adding up to 4. That's just for convenience of calculation, that they have chosen the number 4, I guess. So this, and so the next terms are cyclically written. So what I mean by this, because once you go in more advanced things in inequalities, you can't write out everything, right? So we'll have to go with the cyclic thing. So A, the next thing is B, right? And similarly for B, the next thing is C, and the next thing for C is D. And as you can understand, right, C becomes D, D becomes A. So that's why it's called cyclic. Okay, and obviously this would be a square b, but let me still check the question. Yes, this is okay. So you want to show it's bigger than equal to 2. Yes, so please go ahead and try it, like a similar question.
Wait, is the D supposed to be D squared or is it just D?
Sorry,
The
which
D, is it supposed to be D squared or is it just D? No, like the right one.
it's d square here, of course. Yeah, I mean,
No, the right one.
sorry, the right one. Which
Yeah,
one? This one?
yeah.
It is. Oh, yeah, it's supposed to be D. I'm sorry. Yeah, but it's under. Yeah, it's supposed to be D. Yeah. So tell me, let's see what technique. So if you just try to mirror that technique in this problem, then how should it go? Of course, there might be other ways to do it also.
Mm, I didn't really get anything.
Okay, no problem. Yeah. See, once again, the idea is to get rid of this, right? Get a product there, right? So that we have simple expression simplifies. And to do that, you apply AMGM, right? You would maybe apply AMGM getting to B root C. But again, the question is, problem is that we are on the wrong side, right? If you do 1 by this, then this comes less than, and that's no good for us, right? So we apply that same technique. We try to make it negative. Okay, means we try to bring this kind of thing on the less hand side. Okay, so how do we do this? It's let's try to subtract a 1 or something. Let's see. Let's try to subtract a 1, meaning subtract a 1 from each term. And let's try. I could do it in a more magical way also, but I just want to get the magical in quotes, of course. But yeah, just want to get the idea across. Just subtract 1 on all the terms. And now you try to see this expression. So what do you get? Um, oh, no. If you subtract a 1, then you'll end up with something which is no good, I guess, because it will be a mixture of, you see, you will get an expression like this, right? This is again not good, right? This is not negative, you don't know, because it's a plus minus all mixed, so this is not good. So we'll have to do that more specific strategy. So let me show you. So we can do this. So I'll just subtract. You have to subtract something more specific, but I think it's better. So let's pick out this term. Okay, so we have this a plus 1 by b square c. So once again, what I will do is I will want to get something in the numerator which is a multiple of this. Like, so I'll add ab square c and subtract ab square c. Now you can see this is a
Yeah,
very
I did.
specific reason why, and now you can understand, right? It's a very specific reason.
Yeah, I did that. I
Okay.
did that too.
Oh, okay, then
So
it's fine.
like,
Yeah, nice. So now you just apply. Now you. So now I'll just rewrite the entire thing. Okay. So it will reduce to this. So you can just take that if you have not even
yeah,
done it. Yeah.
yeah, I've done that.
Yeah. Nice. So um, so I'll not write it. I'll just write this so that you try to get used to this notation, cyclic. Okay. Okay. Now, how do you apply AMGM? We know that's why we did all this to apply it in a certain way. So we know what to do, right? So it may not work, but we know what our purpose is here. So this is bigger than, yeah, I should probably not write it in the again, but yeah. So if you flip it over and multiply ABC times B, and you get this, and this is going to be less than a b square c by 2b root c. Okay, and so what does this become? This becomes, am I messing it up? This becomes a root c by 2. No, a b root c by 2, right?
Yeah,
Okay, so now we are getting that this is less than this. So better to write it in full. Okay, we don't want to jump too much because you might end up making a mistake or not understanding what we are doing. You get this. So now, of course, what we would want to do is show that this is less than 2. That's again just a repetition of what we did last time. So you want to show this is less than 2. So this simplifies to showing this is less than 4, which is, as you can understand, this is a much simpler, looks like a simpler question, right? Rather than
yeah,
this. So that's the idea. Yeah, so now I'll let you try this. Okay, so just please give it a try. I'll also try this because this at this point I have to also think of it. So as we did in the previous question, I guess we'll have to apply like consider this as a geometric mean of something, right? And apply AMGM on each terms, right? So it's for, if we apply it very
Yeah.
naively, this is what we will, yeah. So if you apply it like just naively, you will get something like this. This is less than this, right? And similarly for each term. But I do not think this is a good idea. Okay, you will have to do some manipulation to before applying it. So then you would get this, and then you would want to show that is less than 4. But I don't think that's a good idea because we are having these cubes, right? And we don't want cubes
Yeah.
to be less than, yeah, it may still work, but we'll have to see that, yeah. So, or you can just apply it. So just try it. I just come from the washroom. Okay, just 30 seconds.
Yeah.
Yeah. Yes. So
So
any different idea? Yeah, please say.
like I tried a squared plus b squared c by 2 is greater than equal to ab root c.
Oh wait. A square plus b square.
C.
A square plus okay. A square plus b square c. Okay. This
Yeah.
this looks more promising, but see, there is a problem with this also. That again you'll have squares, sum of squares, right? And you again don't want sum of squares to be again on the less hand side.
Mm.
Right, you see, because then you would have to prove that this kind of expression is on the left side, which again we don't want, because all your inequalities, sum of squares is always on the greater hand side, unless there is some special, of course I'm not saying there's no, but yeah, there are in fact. But yeah, these are always on the bigger. Even if you look at Cauchy Schwarz, even Chebyshev rearrangement, all this is always on the bigger side. So we don't want to get squares, and we certainly don't want cubes. Okay, unless it is the sides of a triangle and all, then there are better constraints, but usually this is not good. This is also slightly better than what I did here, but it's not also. So yeah, so you have to apply it in a way that you don't get squares at all. So this is the kind of expressions you want. You're okay with having sums, you're okay with, so see, you will end up with quadratic expressions, like, because this is a 2.5 expression, right? 2.5-degree expression. So if you apply AMGM or any normal inequalities, it will be homogeneous and you'll end up with the same degree. So you can't just get a linear term, a plus b plus something that you can't expect, right? But you can get maybe terms like ABC, AB, BC, CA. These are on the less hand sides of a lot of inequalities. Just like even the previous question we did, right? So with all that in mind, I would like to apply it like this. Okay. So I would not apply it all at once, meaning that I'll keep one of the variables. I'll keep maybe b here, okay, and I will break it up like this and apply it. So break it up like this. Now, when you apply it, you see you get something like this. This is less than this. You see. So I'm avoiding the quadratic and so on. Quadratic meaning in one like square of a term, particular term. I'm avoiding that. Okay. Is that fine, right? So now you see we get this, And so if you did like this, then in the next one you should have make C do the same thing. Okay, so now you can see you get CD by 2. And so this is again a special kind of, but I'm telling you the reasoning so that you can think in that terms.
Yeah,
Yeah, that is
yeah,
the most important thing. So then you have C and CA by 2 and A, and yeah, but there are many other techniques which you have to learn by solving only. But yeah, these are some specific ones, so I'm just telling you. So A, and then what should you get next? D. Yeah, so let's see, hopefully this works. So now I want to show, so this is like I want to show this less than 4. So let's first just simplify everything. Okay, so maybe we can no, it's not a good way to present it like this. So I should just move one step down, and you get this AB. Wait. I have messed it up here. So this should be B here, and this should also be B. Yeah, so it makes sense now. BC, CD, DA. So this is a good expression which is on the left hand side. You can always get that. And then you have this ABC and BCD. Okay, and you have here CAD. In the parts of these problems themselves are problems in themselves. So I think it's not bad. So ABD is less than 8. This is what we want to show. So at this point, maybe I'll remove the original question, or I'll remove the steps, these steps, and shift this up so that you can try it. Okay. So,
yeah,
yes. Yes. So now basically you have to put a bound on this separately, and you have to put a bound on this separately, right? And once again, you don't want squares and all. So you want eventually everything in terms of this. Keep that in mind because that's our condition. Okay. So yeah, with that in mind, you could apply. So this is less than something in terms of A plus B plus C plus D. You have to think something in that those terms. Yeah. At this point, I think it's easier if you think in terms of Cauchy-Schwarz. Okay. I guess that is easier. Uh, no. uh, yeah, you can think in terms of Cauchy-Schwarz. So yeah,
yeah,
um, wait, let me think. No. Even Cauchy-Schwarz will not be good for this. You want to directly bound it. Want to directly bound it with something. Yeah. Hmm. So let me tell you an inequality here. I guess, see, you can do it with ANGM, but it will involve a lot of identities in between that you have to use. There might be a smart way to do it also. But so here is something. So this, when you have this inequality, this is going to be less than, so this divided by 4, okay, is going to be less than, you multiply these terms, sorry, you put these terms in one box, meaning A plus B plus C plus D, okay, divided by 4, and then you take the average of the other part, that is b plus c plus d plus a by 4. Okay, have you seen this type of inequality before? Hmm?
Yeah, I
Yeah,
think I have.
yeah. So this is like Chebyshev. Okay, so
Yeah.
first of all, see, this is like a cyclic inequality, so you can assume that a is bigger than b is bigger than c is bigger than d. Okay, because I mean, if you switch the role, if you cyclically switch the roles, meaning that if you replace a by b, b by c, and c by d, and d by a, the expression is not going to change, right? So it's okay to assume that this order is there. Okay, so now as you can see that uh, this is sorted. So this is an increasing one, and the other one is also increasing, right? So you could, oh wait, the other is not increasing, so I need to find a better explanation for this. um hmm. No, 1 sec, huh? So there are many ways to prove this, but I don't know how to present this one. Yes, that is the problem. Yeah. So, well, anyways, for the time being, we can take it for granted. Okay, this is called the Chebyshev inequality. Okay, um, the proof is, yeah, we may not have the proof. Okay, so, well, so maybe I just state the inequality. It's not difficult to prove, but I don't want to go into the proof right now. For the time being, just assume that I'll just state it. Okay. So see, if you apply this to this and you apply something like this, something same here for three terms, okay, like there are three factors, okay, then you would get that this is less than sigma cube divided by 4, okay, and you would get that this is less than sigma cube divided by 16. All right, then you can finish the problem. Okay, so that's all right, right? Now let me just state the inequality that I'm talking about. So this is what I'm talking about. So if you have, then I'll show you how this is the same. So if you have, let's say, a sequence x1 greater than x2 is greater than x3, just take 4 terms only for the time being, it doesn't matter. And let's say you have another sequence like this. Okay. um yes, in that case, if you multiply the bigger terms with the bigger, like if you multiply them in order, okay, then this multiplication, of course, if you take the average, is bigger than if you first add them, okay, and if you first add them and then you multiply them, right? So this, okay, if you do it in the, if you do it in this order, if you do it in this order, if you don't do it in that order, okay, if you don't do it in the order, then the inequality reverses. Okay, and you see that's what happening in our case, because because our thing is not in order, right? We are not multiplying the biggest by the biggest. Okay, so
Yeah.
here, yeah, here is b, c, d, and a, which is not in that order. So that's why in our case it's reversed. In our case, this is what's happening. So you can see, and the same thing happens for three sequences also. Okay, but it's very easy to remember inequalities. You can just take it. Well, this is a consequence of the rearrangement inequality, but I don't want to go into those right now. Okay, so yes, that is the thing. However, you can always very easily also prove this by AMGM. Okay, that's how it will be done if it's done before Chebyshev inequality. So you can apply this term by term. Um, no, so you will not apply it like that. Okay, so you'll have to apply it in a more smart way. So by AMGM, proving it directly uh, would be would not, but it's not difficult. Yeah, so you can first make this less than this. Okay, you can do this, right? And after that you can add. So what would you do after that? You have this, right? Now, yeah, now you can add 2 times this expression, right? Or I guess you'll have to add 3 times. That depends on this. So you have to do the identity of a plus b plus c plus d plus a whole square. So you will see there are some details there. Okay, this, and now this is equal to a plus b plus C plus D whole square. And you see from there you'll get this inequality. Okay, but this is a much longer way to get there. That's my point. Okay, so that's why I just wanted
Yeah.
to, yeah, that's why we need, otherwise everything can be done by AMGM in the end. All right, so I'm saying that in the end we'll be done with this inequality. Okay, so that was one of the techniques. Okay, now there is technique, I mean there are many techniques, but the other technique which I want to discuss is, so if you remember the question yesterday, which is again, I just wanted things to be extensions of the previous time, so it's not like suddenly something, this question. So here you remember we had to choose the coefficients, we had to choose the coefficients very carefully. So when we were applying AMGM on this, we made sure that we did two times this, right? We took two of them, right? You remember? And then we made sure we took three of these, so that when we applied AMGM, uh, I'm just roughly saying, then you would get two times this product and three times this, three times meaning that multiplied three times cube. Okay, three times this product, right? So that in the end all the variables get cancelled and you get a proper expression. Okay, so now we are going to again apply this on a this kind of technique on a harder question, and we'll see how to actually find out how many times of what you have to take. Let's find out that algebraically, okay, if we can't guess it. So let's start with a simple question. Okay, so which is even connected with the previous one. So zx, you can just take some tx equals to, let's say this is equal to 1 is given. Okay, so this is given, and let's say now the question is, let's say you want to minimize x square plus y square plus z square plus t square. Okay, now before you try this, let me say what this is, like this kind of questions are about. So if you just take, let's say, xy equal to 1, okay, two dimensions, and you want to minimize this, what is this kind of question doing? It's basically saying that your domain is basically saying that, look, this is a function in two variables, right? Of fx comma y equal to x square plus y square, right? It's a function in two variables, if that is clear, right? So basically you can think of it like the domain comes from the xy plane. So this is the xy plane, okay? And the range value we plot on as the height. So for example, at the point 0 comma 0, the height would be 0. Let's say you move to the point 1 comma 1, then the height, it would be at some height 2. Okay, so that will be the point 1 comma 1 comma 2. And in this way, if you try to plot this, you will see you'll get a curve which is like a parabola but then rotated. Okay, it's like a parabola which has been rotated. Now we want to find the minimum of this curve, but under a condition. If there's no condition, the minimum is 0. We want it under this condition. Now this condition is very special because whenever you have an equation, then the graph that you get will also be like a curve. So xy equal to 1, we all understand, right? So do you know what the graph of xy equal to 1 is? It is something like this, right? uh,
Repeat that 1 second.
Sorry. Okay, now I'm saying that, so the function is clear, right? That this is a function from two
Yeah.
variables to one variable and so on. But all I'm saying is that when they give this condition, they're basically restricting the domain of the function to to this, all values which satisfy this condition, right? Means 2 comma half, 3 comma 1 by 3. We'll only consider those values while considering the minimum. Okay, we'll take the minimum on those values. Okay, now I'm saying that this condition actually itself determines the curve. So xy equal to 1 is this curve, right? This curve.
Yeah.
Have you seen, yeah, you know that, uh,
Yeah.
why it is this? Okay, all right. So I mean you can understand that as the values of x increase, the values of y decrease and so on. So
Yeah.
this curve would go on something like this on the plane, right? And then we'll have to take the images of this curve on the parabola. Okay, and then among those, so you can understand that set of images is going to be a bounded thing. It's not like growing arbitrarily big and arbitrarily small, right? That set of images is going to be, oh well, it will not going to be bounded because this is goes on and on, right? So the set of image will not be bounded above, but because this curve is bounded below, at least this point, right? the image of this piece on the xy plane is going to be bounded below on the parabola, and the negative part is not going to create a problem because this is a positive function, squares are there. So in some sense this proves somewhat that the minimum actually exists. Okay, however, you can understand that this is a calculus type of question. It's a condition and a function, and so this can be done by calculus very deterministically without any tricks and such. Okay, however, we'll try to do it by using Olympiads, and later on maybe we can learn
Yeah.
some calculus techniques like Lagrange multipliers and such, which are very useful in a lot of questions. Okay, but recently they have tried to make sure that the questions cannot be done by them, so they have made them more combinatorial. But anyways, we don't have, yeah, we just have to try it. Let's see. So yeah, can you do this? Because this is very easy. This is, I'll just then discuss the actual question, but first let's do this one.
Um, so I got x, y, z, t is less than equal to 1 by 16.
Sorry, xyzt is less than 1 by 16. Okay,
Yeah,
that is no, why, how did you get this?
I took the MGM of the
Mm.
xy plus yz plus cx plus dx.
Oh yeah, yeah, right. So this is cool, yeah.
Yeah.
So this is one problem you've solved. Okay, what do we do with these squares? Sum of squares. So try to bound this below using x because you want to minimize it in this case, right?
Yeah.
But if you bound it in terms of this, you can't bound it in terms of x plus y plus z and so on. Bound it.
Also,
something in terms of this something, just symbolically speaking. Yeah.
Can we like go over the solution quickly because I have another class to do.
Sorry. Okay, okay. You have a
Yeah,
class now. Okay, okay.
yeah, at
Okay,
two
no, no, no.
thirty.
Yeah, that's fine. That's fine. So see, so you want me to do it next time, or do you want me to finish it now?
Yeah, we can finish it now.
Okay, sure, sure. Okay. So see, basically, since it's two at a time, then there is really not many options for us, right? Just apply it two at a time. So probably I don't need to tell you anything more, right? 2yz and just apply it, and you'll get this, right? You'll get that this is bigger than 2 times this expression, right? Bigger than 2. So just applying it two at a time: x y, x square, y square, then y square, z square, t square, and t square, x square. Okay.
Yeah,
So yeah. Okay. So the other problem I wanted to do, I'll just tell you the question maybe. Okay, and you can try it if, because you're saying you have to go. So I'll just tell you the question. Okay, and you can just try it. So this and so it's not totally random. There is 5, and yeah. So this, you have to minimize this. This was the question I wanted to discuss. How do you break up? How do you break the coefficients and apply AMGM? Okay. So you can just think about it maybe next time since you have a class. All right. All right. Okay. Okay. Then see you next time. Okay. Bye. Thank you.
yeah,
Thank you.
yeah.